Hey everyone, it's me again, Mr. H. We're going to finish off this packet from 5.1. We got a few extra problems here to try on this page 6. So it says on this one, sketch an angle of 120 degrees in standard position. Okay, so let's start with that. So I'm going to draw my XY axis. 120 degrees. Well, if I start here on the positive x-axis and I go here, that's 90. So I have to go 30 degrees past that 90 degrees, right? So maybe something like that looks about right. So there's your 120 degree rotation, okay? So that's standard position. And then continuing, find the measure of two other angles, one positive and one negative, that are coterminal with the given angle, and closer to the given angle than any other coterminal angle. So don't go crazy with adding a bunch of rotations. Just do one in the positive direction and one in the negative direction. So I'm just going to go 120 plus 360. That gives me a 480. Right? And then 120 minus 360. Right? That's going to be a negative angle, negative 240. Okay, those are your two angles. Both of those angles would both end up here, right? That's what we're saying. They would just have extra rotations, or in different rotations, I guess. Like the 480 would be, let's do a different color for the 480 to make it stand out. 480 would be, there's 480, right? And then the negative 240 starts here, but negative starts in the clockwise direction, going around that way. Whoa, what did I do that for? Went too slow. Okay, so there would be the negative 240. Okay, but they all end up right there. Okay. So, and then the last thing it says, give the quadrant of the angle. Well, remember with how the quadrants are numbered: 1, 2, 3, 4. So this one's quadrant 2. And I just used Roman numerals, quadrant 2. Okay. That's it for that one. You'll see some similar problems in your homework. Finally, some problems dealing with revolution, and we'll get to this more towards the end of the, or I think a next chapter or something like that. But revolutions, right? We start getting into applications here. So suppose a wheel makes 35 revolutions every minute. How many revolutions does it make each second, right? Okay, so 35 revolutions per minute. We're not talking about the DMS minute second. This is time. Okay, so in the time minutes, right? Okay, so there's 60 seconds in 1 minute, right? So I need that fact. 60 seconds equals 1 minute, right? So 35 revolutions for a full minute. How many per each second? I'm going to have to divide, right? So 35 divided by 60. Okay, let's see what that is. 35 divided by 60, 0.583 approximately. So approximately 0.583. So not even a full revolution in a second, right? That makes sense. It should be less, right? Because if 35 revolutions in a minute, should be less revolutions in a second. Okay, so 0.583. Now it didn't ask this, but what if it asked through how many degrees? And that's going to happen on the next one, so we can try it here too. Through how many degrees does the wheel move in a second, right? So this is 0.583 rotations, right? And one rotation, one full rotation is 360 degrees, right? So one full rotation or revolution is 360 degrees. So if I take this number, and let's just do exact, so 35/60ths multiplied by 360 degrees, right? Let's see what that ends up being. You can always follow along with your calculator, double check me. That's helpful. 210, right? Okay, so there's a bonus question. Again, didn't ask that on number 17, but I mean, this is really the answer for number 17, but I thought, why not? Let's just do a little bonus. Okay, so that makes sense, right? 35 revolutions per minute, 0.583 every second, or 210 degrees every second. Okay, another one similar. A tire is rotating 900 times per minute. Through how many degrees does the edge of the tire move in a third of a second? So let's first, just like the above problem, how many rotations in a second, right? That would be 900 divided by 60. So 900 divided by 60 is 15. So this is 15 revolutions per second, right? And then how about a third of a second? So divide that by 3, right? So that's 5 revolutions in a third of a second per 1/3 second. I guess I can write it like that. Okay, so I know there's 5 full revolutions every 1/3 of a second, but how many degrees is that? How many degrees is 5 full revolutions? Again, there's 360 degrees in a full revolution. I should use that above there, not rot. Let's do rev to be consistent. Revolution's better. Okay, sorry. Back to this, there's 5 revolutions. Each one is 360 degrees. So I would multiply that, right? 5 times 360 to get my final answer. 5 times 360 is 1800. So there's going to be 1800 degrees of rotation every 1/3 second. Circle that because that's final. Okay, so there's the end of 5.1. This will help you get through that homework set. You can always refer back to this video if need be as you go through the homework. If anything didn't make sense throughout this video or any of the previous ones, please let me know and I can explain further. Otherwise, I hope you're enjoying trigonometry. I'll talk to you later.